Ladies and gentlemen, boys and girls, students and teachers, parents and guardians, welcome. My name is Mr. Leaf, and welcome to Mr. Leaf Math. For this video, we'll be focusing on fractions. We'll be focusing on what is a fraction, the components of a fraction, types of fraction. Is it a mixed fraction or is it a mixed number? Alright, we'll later get into a calculation which involves converting a mixed number to an improper fraction and from an improper fraction back to a mixed number. Alrighty? An easy topic is coming. Fractions. Fractions basically represent an equal part of a whole. Alright, that's the long and the short of it. Fractions represent an equal part of a whole. When I think about fraction, I think about sharing something, alright, or representing something of that whole. Alright, so we can get into this that we have right here. So these shapes that we have right here is a whole. Alright, it's just that with each one of these now, they are cut up into different amounts. Alright, but all of this represent one whole. Each one of them represent one whole. Alright, so let's think about it. With fractions, we have what we call a numerator, we have what we call a denominator. Alright, the numerator is basically the top number, while the denominator is the bottom number. Alright, so we're going to use the word numerator and denominator. Those are the words that we're going to use. Numerator represents top, denominator represents the bottom. Alright, with a fraction, the line that you see in the middle is called a venculum. Alright, and I've learned that from high school. It's called a venculum. Many people are going to first time I hear that. Alright, so let's say this shape that we have right here so represents a bread. Have you ever ate Hawaiian bread? Hawaiian bread. So Hawaiian bread is basically a foreign bread. So it basically will shape like this. Alright, so you have some little shaped squares inside of it, and that represents a portion of the bread. It's very, very sweet. Alright, you should try it. Not paid promotion. Alright, so let's say this is Hawaiian bread. So I went home and I looked in the cabinet and I saw Hawaiian bread. So let's say I ate this piece, and I went ahead again and I ate this piece. Alright, feel a little bit more hungry, so I was home again and eat this piece. Alright? If we want to represent the what I've just ate from the bread as a fraction, what I basically do is I draw a venculum, and at the denominator, which is the bottom number, we basically place the amount that the bread is cut up into, or shape is cut up into. Whatever we are sharing, which is the entire whole, is cut up into. Alright? We have 1, 2, 3, 4, 5, 6, 7, 8. So they cut up into 8 pieces. Alright? But how much I've just ate? I've just ate 1, 2, 3. I've just ate 3 pieces of that 8. This represents our fraction, which is this one I have right here. Alright? So this is our denominator. Whilst this is our numerator. Alright, so this denominator, numerator. Denominator represents how much the whole is cut up into, while the numerator represents how much is highlighted, how much we can take out, how much we can focus on. Alright, which is this that is highlighted right here. So, you get what I said? So this, right, is me. So me either. Let's say my sister come in now, and my sister come in and she went there and she circle the bread. Alright, so she eat this piece of bread, she eat this piece of bread, she eat this piece of bread. And to show her eat more than me, she eat one next one. Alright. So let's represent how much my sister just ate from the bread. So let me use green. So green is for my sister. Alright, so great. Alright, as I say, whenever we represent a fraction, draw a reticulum, start off by dictating or highlighting how much is the shape itself cut up into 8, which we have established before. So write that. Alright, but how much slices of bread should just eat? 1, 2, 3, 4. So should just eat 4 slices of that bread. Alright, so every number, every fraction, basically 1 can go into it. Alright, so with that being said, if we divide 1 into any fraction, we're going to get back the same fraction. Alright. However, fractions like this can be reduced into its lowest form, and always reduce your fractions to its lowest form. Once one alone can go into it, you can keep it as it is. Alright, I can't go no lower than that. Alright. However, fractions in case like this can be reduced into lower. Alright. What we need to do with fractions like this is basically reduce it by dividing the numerator and the denominator by a common number. Right? With using a common number, it eliminates the factor of changing the fraction itself, which is changing the value of the fraction. Alright? And we don't want that. Though the numbers might change, the value or what the fraction represents should not change. Alright? When reducing a fraction, you don't necessarily have to use the largest number, the smallest number, or the number in the middle. Right? You can pick and choose which you want to use. Alright? The benefit of using the largest number though is basically lower the amount of reducing that you would have to do. Using the smaller number basically means that you're going to do more reducing. What that basically means, let's say we see that both the numerator and the denominator they are even numbers, and every even number can be divided by what? It can be divided by 2. Alright, so let's say 2 into 4 goes 2 times, and 2 into 8 goes 4 times. So this fraction that we have right here, so which we reduced by 2, is now going to leave us with 2 over 4. Yes, the here now say it can be reduced again, and that's correct. Why? Because this is an even number, and this is an even number, and 2 can be divided into every even number. So 2 into 2 goes 1 time, and 2 into 4 goes 2 times. Alright? That is now going to leave us with a fraction which is a 1 over 2. Alright? This cannot be reduced anymore. Why? Because the only numbers that can go into this, and the only number that can go into both the numerator and the denominator, is 1. Never stop reducing until the only number that can go into both the numerator and the denominator is 1. That's all that matters. Don't stop reducing until the only number is 1. Alright? So this is us reducing by 2. So using the smallest number as opposed to 1. Alright? So if we're supposed to use the larger number now, come here people say, oh, we could use 4. You're hearing through your phone, you're hearing the one. You're hearing through the phone, the laptop, the TV, everything you're hearing through. Alright? So we could use 4. So 4 into 4 goes 1 time, while 4 into 8 goes 1 time. 1, 2. Alright? So automatically, straight down to the half right away. Let's see how this makes sense. Let's see how it makes sense. So people are say, oh, but sir, the number change and the number change, but the value doesn't. The number change, but the value doesn't. Alright, so let's do. We're talking about the 4 over 8, which is my sister, which is green. 1, 2, 3, 4. She have just ate 4 slices of the 8. Think about it. If we're thinking about this going this direction, horizontally. Alright, so we're about to now be eaten. Horizontally. Alright, so this is split up into 2 parts. 4 bottom, 4 underneath. We just see 4. So let's say she never eat piece from everywhere, but she eat the entire top 4. This is basically half of the 8, you know, can cover the entire top, you know. So half of the bread, you know. So this 4 over 8 is basically half of the entire whole lower average. So because 4 is a half of the 8. If I divide 8 by 2, how much I get? 4. If I multiply 4 by 2, how much I get? 8. So that basically is that 4 is basically half of 8. That's why I have this as a fraction. Right? So this represents how much she has it. Alright? Whilst I have it 3/8, she have it 4/8, or you have hit half of the bread of half. Get it? Yeah, no, I get it. Let's take into consideration, this is what our variables are again. So let's say, this is us, right? But this is me. Circle this. I'm beat out the piece right here. Alright, so ready. Let's figure out what fraction is represented by this that I've just shaded. Alright, so again, I'll start off with a pendulum. How much slices is it cut up into? It's cut up into 4 slices, or 4 pieces. Alright, but how much I've just hit, or how much I've just highlighted? 1. See that? That's representing a quarter of this fraction. So this way you see right here, so is a quarter. Alright, so 1/4 or a quarter, or 1/4. Alright, so this represents a quarter. This piece right here represents a quarter of the shape of our fractions. Alright, so let's think about, if I'm supposed to think about the remaining now, let me use green. Alright, thinking about the remaining now. So green. Alright, the remaining, which is green. Draw a pendulum, and we already highlighted that there are 4 pieces that the shape is cut up into. Alright, how much is highlighted by green? 1, 2, 3. 3 is highlighted by green. So that's going to be our fraction. These fractions cannot be reduced. Why? Because the only number that can go to both of them is 1. Alright, there's no other number. Alright, let's look at the third one now. Let's say we have this. So this one is our angry. Alright? That one is our angry. And let's say we talk about what fraction is represented right here. Again, you draw a pendulum. You draw a pendulum and say 1, 2, 3, 4, 5, 6. So we have 6 pieces that the shape is cut up into. How much I've just highlighted? Only 1, 2. So this is going to be a 2/6. Yes, sir? Oh! Yeah, man, it can be reduced, man. Which one can we reduce it by? Oh, yeah, man, we can reduce it by 2. 2 into itself? 1 time, 2 into 6? 3 times. So this reduced fraction would now be a 1/3. Let's see how that makes sense. Let's see how it makes sense. Let's think about this our branches though, it's cut up into 6. Let's think about the groups of 2. 1 group of 2, 2 group of 2, 3 group of 2. 1 group of 2, 2 group of 2, 3 group of 2. Alright? So let's say I've just highlighted 1 group out of the 3 groups. 1 group out of the 3 groups. So I'm saying you're changing the number, not the value. So though 2/6 is the same thing as saying a quarter or a third. Not a quarter, but a third of this fraction or whatever it is, this shape or whatever it is. Alright, so this that we're sharing is a third. Alright? 2 out of the 6 is a third. Let's think about, if we think about the remaining in green. Alright, green. This is right. Alright, so let's think about the remaining in green. So I will start off by identifying how much the shape itself is cut up into, which we have already established, which is 6. Alright, 1, 2, 3, 4. Here, 4. So this remains is 4 of the 6 that's there. Get it? No, not it. Can be reduced again. Yeah, man, here. Can be reduced again. Which number can we reduce this by? Even numbers, don't it? Every even number can be divided by 2. You want to get it? I get it, man. 2 into 4 goes 2 times. And 2 into 6 goes 3 times. So this reduced fraction will now be a 2/3. Alright? Back to the same thing I said. 1 group of 2, 2 group of 2. Out of the 3 groups of 2. 2 groups highlighted out of the 3 groups. See that makes sense? Yeah man, that makes 100% sense. Alright. If you know that, if you realize that for these two, which have highlighted the entire shape but in 2 different colors, if you realize that this 1 group and this 3 group, when we combine them, what you get? A 4, which is all 4. So that will leave us with a 4 over 4. Alright? Once there's any number that's over the same number that represents a whole, that means I take the entire thing. So me and my sister just eat up everything right now. So remember, so red and me and green and she. So we just eat everything. So we eat the entire thing, the whole. Alright? A whole is basically one whole. Alright? So any number over itself, so in this case, the combined thing would have been sister green. Alright, the combined thing would have been a 4 over 4. And every number over itself is 1. Every number over itself is 1. Alright, because every single thing right here is highlighted. Though this is me, this is my sister, combined, everything is highlighted. So it's a 4 over 4. Alright, because all 4 are shaded out of the 4. 4 over 4. Alright, then the number over itself, 1. 1. Alright? And that's the long and the short of the basic or the introduction to fractionism. What is it about? What the numerator represents, the denominator represents, how to reduce it. Cool? Understanding how the reduced is the same thing as the original thing. Alright? Changing the number, not the value. Alright? And that's basically how we work it. Cool? Well, let's get into the types of fractions that we have over here. So we have 2 types of fraction. We have a proper fraction, we have an improper fraction. Proper fraction basically represents these are the shares. Alright? The perfect shares. Why we call it a perfect share? Because we have a whole that we can take from it. That's why it's proper. Alright? So for every proper fraction, the numerator is smaller than its denominator. Why is it smaller? Because the share that's there, we can take from it. We're not exceeding the amount. These are the limits. Because that's what the shape is cut up into. Or whatever we're sharing is cut up into. Alright? Which is the 2, the 3, the 5, the 7, the 9, the 11. So this represents the whole. All of these underneath represent the whole. The denominator represents the whole. Like I said, the 8 pieces, 4 pieces, 6 pieces, denominator represents the whole. The numerator represents how much is highlighted, how much we have take from it. Alright? So with that being said, these are what we call proper fraction. Proper fraction, the numerator is smaller than its denominator. Numerator, smaller, and denominator, proper. That's a proper fraction. Okay? Actually represent the actual share of something. It represents fraction, what fraction is about. Alright? When we get into the improper fraction now, that is basically the opposite of that. Some are against the rule, some go against the rule. Why? Because the numerator is now larger than its denominator. The numerator larger than the denominator. And if the numerator larger than the denominator, it might exceed the limit. Because if me have my shape cut up in a 2, cut up in a 3, cut up in a 4, cut up in a 5, cut up in a 6, and you want to take 3 out of my 2, 5 out of my 3, you exceed the limit. You exceed the limit, man. You take more than what we have. Alright, and how much the shape is cut up into. Get what I'm saying? So, these represent improper fraction, the numerator being larger than its denominator, while proper fraction, the numerator is smaller than its denominator. This is perfect, while this is improper. This is proper, this is improper. This is perfect, this is imperfect. Proper, improper. Get what I'm saying? This represents a good share. Because we can take from what's there. We're not exceeding the limit, we're not nothing at all. Improper fraction go against the rules. I want big man. So if you have 3, no, I have 5 more. No, that's not how it works. So these are improper fraction. Alright? So let's get into this now. Is it a mixed fraction or is it a mixed number? Let's say we go home. Alright? I went home and I my mother come by Friday evening and pay just run. So my mother buy 3 bread. Alright? 3 nice bread. And me can't bother to cook. I'm hungry. I go to circle the kitchen and circle the first bread. Circle the first bread. And me decide I want to eat bread and butter come and I go cook nothing. Alright? We're staggered late when I cook nothing. So I circle the bread. I go to bam and I eat that. Every single bread in my bag. So whole 12 slices will beat off. Alright? 12 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 slices will beat off. So the green represents how much we beat off. So when it goes up home, I beat off the entire bread. So I've just ate 1 bag of bread. Why 1 bag of bread? Because I've just ate 12 out of the 12. And remember that anything over itself is 1. Alright, so that's just 1. So I want to go into the room and they clean a little bit and may use up some energy. Alright, may use up some energy. So you know what I'm going now? Don't judge me now. Hungry again. Hungry again. So you know what I'm do? I circle back the cupboard again, I'm circle back the kitchen and circle the cupboard and I say, alright, I'll eat some more bread. But to my surprise, I eat off the 1 bag of bread again. So you know, go to some eat off all of this again. Eat it off again. Come back, I eat the 12 out of the 12. Cool? Eat the 12 out of the 12. I eat the 12 slices out of the entire bread or whatever it is. Alright? So now, me just eat off 2 bags of bread. 2 bags of bread me just eat off. Cool? 2 bags of bread. Alright? So, when I come in now, she never see me eat the bread, you know. She come in now and she said, she want to collect something down the road for her. Right? Car not there. Sun hot. So you know, so walk, me have to go walk. So I go to boom some. Chat down. Go and take on the walk. Cool. Fall back, sun hot. Me beat out too much energy just use to walk way down the road. I mean, clear complaint me about. So you know what again? Don't judge me, Mr. G. Don't judge me. I'm hungry again. Hungry again. Cool. Come and circle back. I'm not cooking. I circle back again. Circle back the kitchen again. The bread looking at me and I say, come take me. So you see me go so boom so? I'm gonna take it. I'm gonna take it. Go so boom so I'm gonna start beat look bread and butter beat. Mama come in and say, no! You can't eat half bread them so. But by the time she said that, guess what we got already? We got 1, 2, 3, 4, 5, 6 slices of bread. Cool? So me just beat off 6 slices of bread out of how much? Much coming in back again? 12. Me just eat off 6 out of the 12. See that? 6 out of the 12. Alright? Honestly, yeah man, it can be reduced man. Which one am I reduce it by? Oh, we can use 2. Oh, we can use 6. Because 6 is a bigger number. When we use a bigger number, it's easier for work out. Cool. We could have used a 2 too, you know. We can use a 6. So 6 into itself 1 time, 6 into 12 goes much time? 2 times. So you see what going on now? This is the reduced fraction for it. Me just eat off half of the bread. That's how me just eat off. So me eat off 2 full bags of bread, you know? And half more. So in all, how much bread me eat? Me eat 2 and a half big bag of bread. Not 2.5 slices of bread, you know? 2.5 bag of bread. Because that way I think about the bag of bread. Alright? So we just eat off 2.5 bag of bread. So watch it now. This 2.5. What is this called? Is it a mixed fraction or is it a mixed number? Let's think about mixed fraction. Think about the word mixed fraction. We have 2 types of fraction. Proper, improper. Proper numerator smaller than denominator. Improper numerator larger than denominator. So if it's improper, if it's a mixed fraction, that means you have to mix both of them, don't it? So if only if you mix the numerator being smaller than the denominator and mix the numerator being larger, or it will smaller and larger at the same time. No, that can't work. Alright? So this is not a mixed number. This is not a mixed fraction rather. This is not a mixed fraction. What is it? It's a mixed number. Why? A mixed number consists of a whole number and a proper fraction. It's a whole number and a proper fraction. So this is not a mixed fraction, but it's a mixed number. Not a mixed fraction, but it's a mixed number. Alright? So, can't say I learned something new today, no? Not a mixed fraction, but a mixed number. Why? Because it's made up of both a whole number and a proper fraction. Get what I'm going? So, a brief overview. When we talk about fraction, we're thinking about shares. We're thinking about how we share something now. The numerator represents how much is highlighted, how much exists, how much we take out, cool. While the denominator represents how much is there originally out of the entire share before we trouble it any at all. Alright, how much the whole is cut up into. Alright. The colors, if we can go back to the colors, basically represent what we highlight. Alright, so for the red, 1, 2, 3, 3 out of the entire A size is there. So 1, 2, 3, 4. For the green, 4 over 8. Fractions, once there's a number that can go into both the numerator and the denominator, we can reduce it. Alright? We can reduce it with small numbers or big numbers. These are even numbers, so we can reduce it by 2. Whereas we reduce it by 2, it comes down to 2 or 4. We can break down that again to a half. Alright? Whilst we use the largest number, go straight down to half. Feel me? Yeah. Next thing, for this, same thing. Alright? Red, quarter. Green, 3/4. Alright? Same thing for this. 2 over 6 for the red. Break down to a third. Alright? Because it's one group out of the 3 groups out. Cool? And likewise, for the green, 1, 2, 3, 4. 4 out of 6, which is 2 groups out of the 3 groups out. 2. Feel me? You want another one. Type of fraction, proper, improper. Proper fraction basically have the numerator being smaller than the denominator. Improper have the numerator being larger than the denominator. Alright? And the examples are there to show. Mixed number represents a whole number and a fraction. So that for the scenario is one that I gave, which is basically having 3 bags of bread, eat off 2 full bags, and I eat half of one. So I've just ate 2.5 bags of bread. Alright? And that is it as it regards to the introduction, the basic foundation of understanding fractions, type of fractions, how fractions are represented, how we can think about them to help us understand them. That's Mr. Leaf. Please like, share, and subscribe. See you in the next one.